So some of them used to play very good. I used to like them. I used to hold their picture. My bedroom literally have 10, 20 of pictures of their star cricket player. I don't know what you guys do. You guys maybe pop star or like baseball or football player you do, right? And the girls do what? Some actress?
Volleyball.
Volleyball? Okay, very good. Something have you do always follow, don't you? Someone like makeup. Those who does good makeup, you follow her style, right? Someone like to sing. Tristan, maybe he looked like a good singer. Maybe he sings. Do you? Oh, I did a mistake. Okay. So if that happened, you follow. If you're a singer, suppose. Okay, let's make it up. Then you follow that singer style, hair, same guitar and stuff, right? Exactly in periodic table, the same thing happened. These guys are like our star. Again, I don't have any star right now, but when I was your age, So these are like our star. We all follow it. We all want to follow. They don't follow anybody. We all follow them. We all follow them. We all become like that. We'll talk about that, chapter 9, next class, in details about the analogy I give it to you. But at this moment, look at this guy. Where is it? Right here, right? So when it becomes like 10, what does this 10 mean? Electron or proton? So certain electron, losing 1, losing 2. What is it? 10 means number of electron, yes. So number of electron 10, tell me who are like number of 10 electron in periodic table? Neon. So this aluminum tried her best. Forget about my previous example. Now it's going to mess you up. Okay? If you look at my previous example, look at the aluminum, and look at the mother with the 3 child, that'll be a big mistake. Okay. Go a different example. So aluminum trying its best to losing all 3 electrons. Why? It wants to be like a neon. Isn't it? Like for instance, I don't have hair here and here, right? If someone have a good hairstyle, I like to follow my role model, my star. What I'm gonna do? Take off all the hair out, get a new hair in, okay, and cut hair like that. I did so many things to make my hair like my star. Aluminum did so many things. Why? Because it wants to be like a neon. So this is actually a lot of chemistry we'll be learning next chapter. Let's go back to today's chapter, okay? You always keep taking my point. So noble gases are like our star, okay? If you keep in mind, you'll see chemistry gonna be so easy, lot of chemistry, okay? So we'll talk about that in the next class. And only thing we need to know is in periodic table, noble gases are only one group, and if you go top to bottom, ionization energy decreases. A same trend like others, because if you go top to bottom, size increase, but ionization decrease. Noble gas happens same thing. Noble gas is also decreasing their ionization energy as it goes from top to bottom across the group in a column. Then what is it? Electronegativity. Who are the electronegative in periodic table? Who they are? Can you tell me one of the electronegative atom from the table? Electronegative atom from periodic table. Hurry up. Electronegative atom in that periodic table. You don't see any?
I see a lot, I just can't read it.
You can read it? Okay. Remember that the very right side, like fluorine, chlorine, bromine, oxygen, sulfur, selenium. the right side, right before noble gas, is called electronegative atoms, like few of them, very few, handful atoms are electronegatives, right? So what is this means? This means that the atom is able to accept electron. The ability of accepting electron, the ability of pulling electron, that's called electronegativity. Ability of pulling electron. For instance, if I have an example, H chlorine, right? Hydrochloric acid. So this chlorine is electronegative much more than hydrogen. That means if it is bonded with the chlorine, it pulls electron from hydrogen. That's called electronegativity. So if we go from, okay, let's try to compare. Electronegativity is completely opposite with a ionization energy. So look at that. Let me give you an example in here. Let's go to chlorine, okay? Chlorine is 17, right? Chlorine takes the electron, become chloride ion, and it becomes 18. You see? What happening in here? It's losing electron, which needs energy, right? What happening in here? Taking one, accepting electron, that's becoming negative. It become positive, then become negative. That's called ionization, right? So positive ion, all the metal. Who are the metal? All the atoms, transition metals, group 1A, group B, all transitions are called metals, except those few. So between metals and non-metals, there is some metalloid in them. We'll talk about that in next class. So at this moment, let's see how electronegativity goes. So cation, anion, right? And all anions are electronegative. Because chlorine has electronegativity, it accepts electron, it becomes an anion. And in a bond, how you see in a bond? In a bond, chlorine pulling electron towards itself. That means this chlorine is able, it has the ability to pull electron because it is electronegative. And that property is called electronegativity. Clear? So then how the trend goes? First of all, if you go size go top to bottom increase, right? And also right to left increase, size, right? How about the ionization? Other way. Completely opposite, right? Opposite. Electronegativity also same. It will be increased from bottom to top. Electronegativity increase from left to right. Yes? Let me give it. Then let me ask you a question. Aluminium and cerium. Let's go very first thing we learn. Which one is bigger? Aluminium. And then which one is mostly electropositive? So let's go. Actually, I will talk about ionization energy. Which one have higher ionization energy? Silicon. The third question. Which one has high electronegativity? Silicon as well. Because electronegativity and ionization energy both are inversely proportional to size. Exactly, to the radius. See? Now it's very easy for you, right? Let me ask you more question. This is like summary for you. Across the period, it will increase and decrease down the group. You see here in a visual presentation for you. If you go from left to right, see, it's increasing, you see? If you go top to bottom, it's decreasing, right? This is applicable both for electronegativity, both for ionization energy. Okay? But size, radius will be the opposite. Clear? Wonderful. So what is electron affinity? Whenever you hear the affinity, the word affinity means something you like, you have an affection of something. Affinity. You know, I like you. I have a strong affinity to you. You know, that's called affinity. So, electron affinity means who loves electron, who loves to get extra electron. Tell me an answer. If I ask you, metal or non-metal, which one should have electron affinity? Non-metals. Why? Because they are the one accepting electron. You saw in here. It's accepting electron. That means it has electron affinity. Does it have electron affinity? Yes, it is, but it's very less. You know? So very less. Because these have electron, these lose electron. It want to release electron. And you know why it want to lose electron, right? Become a 10 electron, which is neon. Like your star. You're gonna be like your model. See? The same reason. Let me show you other reason. Chlorine is 17, right? It accepting electron become 18. Tell me who will look like 18? Argon. Is it argon a star? Yes. Not everybody likes same star, right? Everybody has their own star, right? Look at the aluminum, choose star is neon type. Chlorine, it chooses like argon, which is called isoelectric element. Remember, isoelectric element. Electron number is same for two element. That's called isoelectric. So aluminum become 3+, being 10 electron, and neon also 10 electron, right? They are called isoelectric because their electron affinity, their number of electrons is same. See? And you see, this is also proportional to electronegativity, because electron affinity means attracting electron, and electronegativity means accepting electron. Both are same, right? Something like, you know, I eat sweet because I like sweet. You see, electronegative because it likes electron. So they should be proportional. Makes sense, right? Wonderful. So this is the final critical stuff for you. I know it's so many things, right? I try to give you everything in a live example, so hopefully that'll be easier. So look at the lithium and lithium plus. Okay? Let me go in here, that'll be easier. So lithium, where is lithium located? Lithium located in here, right? 2s1. So this is lithium, this is, and then this is beryllium. So when lithium lost an electron, it become lithium plus. Lithium, this is lithium, right? So it lost the electron, become a lithium plus, okay? Plus. So in lithium plus is so when it lost the electron, it become its actual shield. It become, lithium was here. When it lost electron, it go back in here. You see, it was here, somewhere in here, because it's second level. Lithium, look at the picture. Isn't it second level? Second period, second energy level. When it lost the electron, it go back to helium. Which level helium is in? Elizabeth, which level helium is in? First level. So lithium was in second level. When lost electron, it go back to helium. Because look at the lithium, how many electrons lithium has? 3. By losing an electron, right, it become like helium, it become a 2. And helium has 2 electrons, right? So 2 means first level. That means by losing an electron, it go one step back. It go one level back. Tell me if it is so, tell me, so if it losing electron, it becoming smaller or bigger? Smaller. Because it going back to one level, actual level. The red here showing that it goes back to the actual shield. The outside is the one electron makes it bigger. Make sense? So let me ask you a question. Then sodium and sodium plus. Okay? Which one is bigger size?
Sodium.
Sodium. Wonderful. Iodine and iodine and iodine minus. What happening in here? It gaining electron.
Oh.
What happened when you gain electron? I don't have example in here. You maybe remember.
Gets bigger.
Get bigger. Look at that. Iodine was in here, right? 5th level. When it gaining electron, it become 54. So being 54, it fulfilling its level. So being negative was here, right? Suppose iodine, there you go. I have it here. So iodine is this size. When it gaining electron, it goes upper level, getting bigger. It gets one more level, right? So now tell me, I have these three examples. Anion, cation, and atom, neutral atom. Tell me which one is the largest size?
They're all facing left.
Which one is the largest size? Anion is the largest size, right? Then,
The neutral.
which one is smallest?
The positive.
Positive. You see the trend is? You can do that? If I have more example for you, more questions like that?
Yep.
Wonderful. So look through the slide and read the book. Again, you have to read the book. This is your Bible. You have to read the book. Okay? And let me see what I have for you. I have metallic character. What is metal? Can you remember some character of metal?
Shiny.
Shiny. I like shiny, and metal is shiny.
Malleable.
Malleable. Oh, that's not good. Okay. So metal is malleable, shiny, and ductile, and hard. What else? It conducts electricity.
Malleable.
Malleable. So a lot of property, right, in metal. So there's the metals. So metals are metallic. If metals form a oxide, tell me a metal name from here. Gold. So gold, right? Gold oxide. So gold oxide is called metallic oxide, right? And metallic oxides are basic. So when metals form oxide, they are called basic oxide. The reason is metal reacting with water. When metal dissolve in water, look at that, what happened. It becomes aluminum. Look at that. When metallic oxide dissolved in water, it becomes metallic hydroxide. Metallic hydroxide means it is a base. Any compound have a OH, that's called base. Remember? Remember that? Yes. So it becomes a base. That's why metallic oxide are called basic oxide, because in dissolving in water, it gets basic property. How about non-metallic oxide? Can you give me any non-metal name? Oxygen. So give me one more. Carbon. So carbon is carbon dioxide, right? That's called carbonic non-metallic oxide. So non-metallic oxide are called acidic oxide because it dissolves in water, right? From a H2CO3. You see? In dissolving in water, it becomes an acid. You know acid mean, right? Have a H in the left side. You learned that. Good. So non-metallic oxide form a acid dissolving in water. Metallic oxide forming a base in a water. That's why metallic is called basic oxide, is called acid oxide. Okay? So few other property, group 2A, what the group 2A? They are called alkaline earth metal. And group 1A is called alkali metal. One NS1, NS2, and group halogen, the last one, right before star, right? We don't talk about the star that much because they are very noble, right? They are noble, that star, we follow them. We try to be like them. So all other atoms try to be like them, and so until at the last atoms are called halogens. It's called 7A. It's called 7A, right? So 7A is called halogens. Their structure is like NS2 and P5. Because 1, 2, 3, 4, 5. Each box is 1. There's the P. So P5 and S2 and P5 is a halogens configuration. Noble gas is a noble. The nobles are NS2 and P6 because there's a 6 box. Right? 6 box. Oh, that's all. So hopefully you guys learned something today and get ready for the quiz. Oh, learned a lot?
Yeah.
Oh, thank you.
That's good.
So, learn something? Wonderful. Learn a lot too? Okay, good.
Here you go, man.
So we'll have a quiz next class, right?
Yeah.
Okay, get ready for this.